Okay, let's start marking. We finished marking 2A, am I correct? Yes. Okay. B, not finished, no? Okay. So when I look at the sum, the first thing I did there is I changed that order that I see right there. So I took out a negative and then it became 90 degrees minus theta. Okay, do you all understand that? Here, I also saw another problem. That 720 is too big. I don't know in which quadrant that is because the angle is greater than 360. So all I did is I subtracted 360. Now there's two ways that you can do it. You can either subtract it once and then you have 360 degrees minus theta, or you can subtract it twice. Then you just have negative theta. Both of them will result in the same answer. Okay, it doesn't matter which one you choose. Okay, now I start. I say the cos of a negative is the positive cos of the angle. So I haven't changed the angle yet because there are many things happening at once. Don't skip steps. You're going to make a mistake. Right, that one I changed and that one I just wrote correctly. Now I'm going to go to the reference angles. 90 minus which quadrant? First, 90 sin theta. The tan of a negative angle is negative tan of the angle. The sin of a negative angle? Negative sin of the angle. I use this one, the tan of a negative? Negative tan of the angle. If you use 360 minus, it would be the same because it would be in the fourth quadrant, and in the fourth quadrant tan is negative, so either way it would be negative tan theta. Alright, the sins cancel out, the tans cancel out. Negative divided by negative times by negative gives me negative 1. Remember, just the correct answer does not mean you got it right. This is where we get our marks. Can I page? Okay. So what I have here is once again a negative angle. There, it's the wrong order. And don't be, I don't know if we said it yesterday, but don't be scared of this thing, this beta. It's just the same as theta. It's a variable for an angle. Okay, so it makes no difference. But I took out the negative there, and then it will be 180 degrees minus theta, minus beta. That one isn't right either, so I take out the negative, then it's 180 degrees plus beta. That one is fine, this one is fine, this one is fine. You all agree with that? Okay. Now I'm going to get rid of those negatives. The sin of a negative is negative sin of the angle. The tan of a negative? Negative tan of the angle. That one I just left as it is. This one I already changed. The cos of a negative is? What? Positive cos of the angle. Remember, cos doesn't go to negative. And then that one is fine. Now I'm going to change the signs because of the quadrants. That is the second quadrant, the third quadrant, the third quadrant, and the first. Do you see that one? 360 plus. We haven't come across one like that before. But if you're around one time, 360 plus, that would just put you in the first quadrant. Do you agree with that? Okay. So sin in the second is positive, so I've got a positive and a negative that makes it negative. Tan in the third is positive, so I've got a positive and a negative, that's a negative. Cos in the third, that's a negative. That one is already done. Sin in the first is a positive sin beta. I'm just going to make it one bigger. Grade 11s, do you understand everything I did there? Who says, I can't hear when you say no? Then you put up your hand and you ask me. Who says no? Do you all understand? Do you see I put in the multiplication signs? So that I don't think that this is a sum that has more than one term. It has one term. And that means I can cancel out. So I'm going to start and cancel out sin and sin, cos and cos. Then I've got negative, negative, and negative. So my answer is negative tan beta. We got it right. Good. Okay, the next one, it was tan negative 50. The tan of a negative? Negative tan 50. The cos of negative 240? Positive cos, but then not 240, ne? 180 plus 60. Maybe you used 270 minus 30. Who did that? Then you must remember to change cos to sin, ne? Okay, then it will be fine. In the third quadrant, cos is negative, so it's negative cos 60. We spoke about this one yesterday, ne? Just because the cos of a negative is positive doesn't mean the answer always has to be positive. It depends on, after you've gotten rid of the negative, in which quadrant you end up being in. Right, the sin of negative 20? Negative sin of 20. The tan of negative 210, the tan of a negative? Negative 10 and 210? And then that's in the third quadrant, so that's positive for tan, but there's already a negative, so it's negative tan 30. Okay, cos of negative 135. Wait. No, that's not what I'm asking. The cos of a negative is positive. Positive cos. And then it's 180 minus 45. If you use 90, you must change cos to sin. In the second quadrant, please just behave. Okay? Cos in the second quadrant is negative. Therefore, it's negative cos 45. Grade 11s, there are many things happening in one question. You have to concentrate. Don't make it more difficult than it has to be. Okay. The sin of a negative? Negative sin, 125? Minus 55, that's right. Sin in the second? Positive, but I already have a negative, so it's negative sin 55. Tan of 650. Now this is the one where it's gone past one revolution. So we just subtract the 360, ne? So if I subtract 360, I end up with 290. Right, 290 is still not reference. It's between 0 and 360, but it's not reference. So what must be in the bracket? With tan. 360 minus 70. Don't use co with tan. Okay. 360 minus 70, that's in the fourth quadrant. So it's negative tan 70. Cos 765, I subtracted 362 times. And then it's just cos 45. Right, sin 485, I'll subtract 361, then I have 125. 125 is not reference yet. I say 180 minus 55, that's in the second quadrant. So it's positive sin 55. Okay, the sin of a negative is the negative sin of the angle, but 415 is too big, so I subtract 360, and then I've got negative sin 55. Are there any questions? Okay, now the following example that we're going to do is a typical exam question. It's not new work. It's all of the things that we've been working with thrown together. So it's reference angles, it's cofunctions, and it's negative angles. And then they've just added one extra trick for us to be able to do it. Okay, so it's not a new heading. You can just write NB exam question, and then you can write example 1. Okay, so what they do in these type of sums, they give you a trigonometric function, the whole one, the function with the angle. Okay? So do you remember when we started trigonometry, I said this. I said cos alone is nothing. 20 alone is an angle. Cos 20 is a ratio. Do you remember that? It's a side divided by a side. Very, very important. So they're giving you the whole ratio, and they are telling you that it's equal to t. Now remember, for all practical questions that we are going to do in trigonometry, we are not going to use a calculator. There is, I think, one part where we use the calculator with these sums, or not with these, with the current part of trigonometry that we're busy with, but we're not even going to do that because they don't ask it. You can imagine they're not going to ask you to do a calculator sum on your calculator and get marks for it. That time has passed. Okay? So you must remember, every question will have the instruction without the use of a calculator. So you don't use a calculator. Don't cheat with the calculator. Alright. Now the question is to determine in terms of t. Determine in terms of t. Do you know what it means when I determine something in terms of t? There can be numbers in your answer. There can be exponents. There can be calculations. And there can be a t or t's. That means you're not going to get a specific answer. You're not going to know that the tan of 20 is 0.52 or whatever. You are going to get to an answer like the tan of 20 is t squared divided by 5 or whatever. So that means there must and most probably will be the variable t in your answer. Okay. The moment that they ask you a question and they ask you to give it in terms of t, that makes t no longer an unknown. Do you hear what I mean? Because it can be in your answer. You don't have to solve t. It can be in your answer when it's in terms of t. Okay, so the first one, this now you have to write the answer in terms of t. The cos of 160. So our calculation and our plans haven't changed. Can you see 160 is not reference? How can we write 160? 180 minus 20. Okay, now we do it in the same way. That is in the second quadrant. What is cos in the second quadrant? Negative. So it's going to be negative cos 20. Now if cos 20 is t, what is negative cos 20? Negative t. And that's all you do. Don't get comfortable. Next one. So you see now they throw in the negative as well with the reference angle. So they're asking you to find the cos of negative 200 in terms of t. What is the cos of a negative? Sure, guys, really, that's like the one catch, and I keep catching you. The cos of a negative is the positive cos. 200 is not reference, I rewrite it as 180 plus 20. Which quadrant is that? Third. Cos in the third? Negative. So it's negative cos 20. So what is this in terms of t? Negative t. Okay, 250 is not a reference angle. Now we can write it as 180 degrees plus 70, and then we would have negative sin 70. Do you see we don't have anything we want? We want cos 20. But who knows what the trick is here? 270. Why 270? Then it's going to change to cos. And do you see, have you noticed that the cofunction angles, the sum of the two angles will always be 90. So if that's 70, what will the cofunction angle be? 20. And that's what we want. We want sin to become cos. We want 70 to be 20. So instead of choosing 180 plus 70, I would rather choose 270 minus 20. Do you remember I told you there will be a situation where you have the choice of using the cofunction? This is an example of that. So that's when you use the cofunction, when you need it. Not every time. You're going to make mistakes. Okay, which quadrant is that? Third. What is sin in the third? So it's going to be negative cos 20. So what is it in terms of t? Negative t. Okay, sin 20. Right, with the knowledge that you have, I want you to just do it in pencil. See if you can get sin 20 in terms of t. Please tell me someone has a plan. Okay, try. Why 0? Okay, remember at least she tried. But remember 0, 1, 80 and 360. They're the same. So 0, 1, 80 and 360 doesn't change the function. But I get the idea that you all see the problem here. When we change sin to cos, we have a plan to change sin to cos. But then the angle is wrong. Did you notice that? Then the angle is going to become 70. And if we have the angle right, 20, we don't have the right trigonometric function. And that's where we are at now. And that's why I said don't get comfortable. Okay. So here we go. Listen to me. Look at me. Whenever you see a question like this in a question paper, they will ask a 1.1, 1.2, 1.3. The last one will always be this type of sum, where you're going to have to get a diagram. So no one tells you to draw a diagram. You must know you draw the diagram. Okay, so make a note there. Draw the diagram yourself. Now what I would do is, before I'd even start the sum, before I even do the easy ones, I would already draw the diagram because I know it's coming up. Okay. Now the thing with a diagram, remember we're not allowed to use a calculator. The thing with a diagram is, if you have a diagram is just having a triangle. Okay? And you don't even need to have the angle size. Okay? But if you know the lengths of all the sides, you can calculate the sin, cos, tan, anything of this angle. I will call it x, I will call it y. That angle must be 90 degrees, because it's trigonometry. If I have all the sides lengths, they can ask me anything. If they ask me the sin of cos, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. They can even ask me, I might have been working with x the whole time. They can even ask me something about y. Sin is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So I don't need the angles. That's why you don't need a calculator. Because we're going to calculate the lengths of the sides. Okay. But what makes this difficult is because we don't have the side lengths. We don't have a value 3, 4, and 5. All we have is t. Okay, so look at what happens. I wrote here the problem that you might have come across. So I hope you also did that. So when I look at cos 20, you guys remember when I started the sum, I told you we have a ratio. A ratio is a fraction. It's a numerator over a denominator. So if I have cos 20 is equal to t, and I want to write t as a fraction, it's t over 1. Do you agree with that? Okay. What sides make up the cos ratio? Adjacent over hypotenuse. This means that the adjacent side is t, and the hypotenuse is 1. So when I draw my diagram, and I'm going to explain to you why I draw it in this way. This is the x-axis. This is the y-axis. Where is 20 degrees? In which quadrant? The first quadrant. No, that's why I draw it here. So we always take our radius out, and we take our side down. Never to 90 degrees. Because 90 degrees is cofunctions. It would be completely different than what I'm busy with here. I take it to the 0, or if I was in the second quadrant, I take it to the 180. If I was in the third quadrant, I take it up to 180. If I was in the fourth quadrant, I take it up to 360. Never to 90 and 270. You understand what? Okay. So I draw the triangle here. It must have a 90-degree angle. The angle that I'm working with is always the one closest to the origin. Okay? I said that cos is t over 1. That means the adjacent side is t and the hypotenuse is 1. Do you all understand up to there? Because the explosion is about to come. Okay. Do you know of a method that can help us to calculate an unknown side? Now the reason, let me just give you the reason. The reason I want this unknown side is because I want the sin of 20, and sin is opposite of hypotenuse. Even if I use the cos 70, very important to take note of this. Do you see there is a 70 degree in that triangle? Do you guys see the 70 degree? It's this one. It must be 70. Because the sum of the interior angles are 180. So even if I have the 70 degrees, then I need cos. Cos is adjacent of hypotenuse. So I need the length of that side. I have a 90-degree triangle. Have you learned some method to help us find the unknown side of a 90-degree right-angled triangle? What is it called? Pythagoras. Okay. So you understand what we're doing, why we're doing it. But what makes it difficult is doing Pythagoras in terms of t. Okay. So the secret to mathematics is everything stays the same. If there was a 3 and there was an unknown and there was a 5, you would say 5 squared is equal to 3 squared plus the unknown squared. We prefer to call this side y because it's the y coordinate. Does that make sense? Okay. That would be the x coordinate, that would be the y coordinate. Right. So you do it the same way. All you're going to do is you're going to say hypotenuse is 1 squared equal to right angled side t squared plus y squared. Y is my unknown. Remember when we started I said when they say in terms of t is no longer unknown. It's fine if t is part of it. Now all we're going to do is we're going to try to get y alone. Then y will be in terms of t. So what we're going to do is we take the t squared over. Nothing new. And then I take that square over. And then it's the square root of 1 minus t squared. And that square root of 1 minus t squared, that is the length of the side. It is in terms of t. There's a square root. You are fine. You know what the square root is. There's a 1. It's known. 1. And there's a t. T is no longer unknown because they want it in terms of t. Do you understand, grade 11s? Okay? So I said now if you have all the 3 sides of a triangle, they can ask you any sin, cos or tan function. So now you can pick and choose what you want to do. If you want to give them sin 20, that will be opposite over hypotenuse. So it will be root 1 minus t squared over 1, which is just root 1 minus t squared. If you choose to give them cos 70, it will be adjacent over hypotenuse, which is also root 1 minus t squared over 1, which is root 1 minus t squared. They also asked a question E. They asked the question E, tan of 20. Now because I have all the sides, it's no problem. The tan of 20 is opposite over adjacent. So you can immediately give that answer. If you're done, you can open your textbook on page 150. I think it's 150. We're going to do exercise 5. I'm going to do another one like this with you. And then you're going to do 2 of them for homework. Are you all done? We're still busy. Come on, come on, come on. You're wasting our time. Are you done now? Okay. I'm going to do A with you. So you do it with me. Don't just copy. Okay, so what they're giving you at number 1 there is that sin 40 is equal to P. Then they say write the following in terms of P. So you understand what it means when they say in terms of P? It means P is no longer unknown. P can be in the answer. P will be in the answer. Must be. Okay. So the first one they want you to calculate is sin 140. So as I say, when you know this, you know what's coming. I would have already drawn the diagram before I even start. But let's just go on until we need the diagram. We'll do it normally now. Okay, rewrite 140 for me. Which quadrant is that? Second. What is sin in the second? Positive, so this is just sin 40. Therefore, it's just P, just as it was. Right. B. Sin 220. Please rewrite 220 for me. Which quadrant is this? Third. What is sin in the third? Negative. So it's negative sin 40 degrees and therefore it will be negative P. C is sin negative 140. So first we get rid of the negative, ne? What's the sin of a negative? And then how will I write 140? 180 minus 40. Which quadrant is that? Second. What is sin in the second? But I already have a negative, so it's negative sin 40 degrees, so it will be negative P. D, cos 50 degrees. I don't want the 50, I don't want the cos. 90. Cos 90 degrees minus 40 degrees. Okay? So, this is in which quadrant? First, so it stays positive, but sin 40. So this one is just, again, P. Sin 50 degrees. If I use 90, the sin will change to cos, but then my angle will be right. We have to draw the diagram. Okay, so 50 degrees, in which quadrant is it? First quadrant there. So you can just draw it there on the side. You just draw it roughly. Don't go and get your art and culture sketches here. Don't even use a ruler. Okay, so we always take the radius out and it must always go down to the 0 or the 180 degrees. That angle will be 90 degrees and this angle here is 40 degrees. Remember, we are now referring to the original thing given. The original thing given was sin 40 equal to P, because this is what we have. So I put that 40 degrees in here. What do I know about that angle? It's 50. Doesn't mean I'm going to use it, but it's good to know. I have options. I told you that sin 40 is a ratio. So therefore it's P over 1. Sin is opposite over hypotenuse. I need to calculate the length of this side, which we will call x. X is unknown. We have to find x in terms of p. How do I find the unknown side? Pythagoras. Pythagoras says 1 squared is equal to p squared plus x squared. Okay. So the p squared goes to the other side. 1 squared is 1, no? That's why the square goes away. So it's 1 minus p squared, and then I somewhere take that square over to become a square root also, and then my answer is just x. So now that is the value of this side. And now I can give the answer of sin 50, or I can give the answer of cos 40, whichever one I want to. I wouldn't even go and use the cofunction. It's just another minute that you waste. Okay, so I know that angle is 50. I want sin, its opposite over hypotenuse. So therefore the answer will be the square root of 1 minus p squared. And you don't go and do this on a rough page and throw it away. Don't do it in your head. Don't memorize the whole thing and don't write it. I have to mark here. Okay, so I have to see the diagram. Okay, and then the last one they asked for, F, was tan 220 degrees. Don't use cofunctions, ne? How am I going to change tan? 180 degrees plus 40. Which quadrant is that? Third. Where tan is positive. So it's just tan 40. I read from the diagram. There's 40 degrees. Tan is opposite over adjacent. So therefore my answer is p over root 1 minus p squared. And it's fine if that answer is goga like that. It's in terms of p. That's all we want. That's all you have to do. And then you can do question 2 and 3 for homework. It's the same. 2 is cos, 3 is tan. So all that's going to be different with tan in your diagram is when you draw your diagram, you're going to have opposite over adjacent. And then you're going to calculate the hypotenuse. Same way. Everything on one side, take the square over, square root it. You got the answer.